Look at this vast floating expanse. Every single day, modern enterprises generate petabytes of raw, unstructured data. When organizations look at this volume of information, they often treat AI as a generic, all-purpose software fix. This lack of technical specificity is the primary reason large-scale enterprise projects fail. To extract actual value from these billions of data points, we have to split artificial intelligence into two distinct mechanical engines. These engines answer two entirely different questions. One looks at the data and asks, what will happen? That is predictive AI. The other asks, what could this look like? That is generative AI. Navigating the difference between these two paths is the line between deploying reliable autonomous systems and simply drowning in raw telemetry. Let's look at the first engine, predictive AI. This system runs on highly organized fuel. It requires structured data with clear, distinct labels, the kind found in database rows, columns, and sensor readings. Notice how these scattered data points align into a strict historical pattern. The algorithm mathematically forecasts a specific future outcome, outputting a precise, measurable probability, like an 87% chance a customer will cancel their subscription next quarter. Because of this strict mathematical mapping, the predictive engine is completely deterministic. Feed it the exact same inputs today and next week, and you will receive the exact same prediction every single time. This is the quiet workhorse of the modern economy. It is the system that instantly flags a fraudulent credit card swipe at a terminal, or tells a factory manager that a critical machine part is likely to fail before it actually breaks. This engine does not invent anything new. It acts as a high-precision radar, illuminating exact risks and opportunities on the horizon. The second engine, generative AI, thrives in chaos. Instead of clean spreadsheets, its fuel is massive pools of messy, unstructured data, text documents, PDFs, images, and loose code snippets. These systems use deep architectures, like transformers, to learn the complex relationships between words or pixels. They use those patterns to synthesize content that has never existed before. Technically, a large language model operates by predicting the most likely next word in a sequence. However, its functional, practical purpose is generative creation. Watch how this central prompt yields numerous potential outcomes. This variance exists because this engine is probabilistic. Randomness is baked into its design, meaning the same prompt can yield different results. Organizations use this flexibility to generate novel, context-aware content. It can autonomously draft a 50-page compliance report, render high-fidelity marketing images, or rapidly debug complex software architecture. If predictive AI tells a business exactly what its data means, generative AI imagines what the business can build with it. To reach true automation, these two distinct engines must eventually converge. Let's look at customer retention. First, the predictive model scans thousands of user interactions to forecast exactly which customers are most likely to leave. It passes that specific list to the generative model, which instantly drafts highly personalized retention emails tailored to each individual's history. Executing this handoff introduces a massive operational hurdle. Making this pipeline work requires feeding both models highly sensitive, proprietary corporate telemetry. If a company relies on public, third-party AI APIs, they face two distinct threats. First, the probabilistic nature of generic models can lead to hallucinations, destroying the accuracy of the data. Second, transmitting proprietary information externally creates a direct risk of intellectual property exfiltration. As we see here, the most sophisticated automated workflow is useless if it leaks your intellectual property. Enterprises require a secure, sovereign wrapper. This is the exact challenge Treecapital Technologies engineered Anven AI to solve. Anven is a sovereign intelligence layer designed to live entirely within a company's own firewall or even inside an air-gapped virtual private cloud. Most generic AI models act as a black box, an opaque, probabilistic system where you cannot see exactly how your data is used. Moving away from that opacity, Anven offers a deterministic, highly engineered architecture, rigid enough to demand absolute precision. To ensure that precision, Anven operates within a native Retrieval Augmented Generation, or RAG, ecosystem. It forces all generative outputs to be strictly grounded in verified database facts, driving a targeted reasoning accuracy of 95%. It also utilizes a late fusion multimodal architecture. This allows the model to process complex visual diagrams and linguistic data simultaneously in a single secure environment, without relying on external third-party tools. Because intelligence needs to happen everywhere, Anven is edge-native. These models can run locally on mobile hardware or embedded devices, delivering near-zero latency without requiring a network connection. Deploying AI at scale depends on coordinating both prediction and generation within a secure, sovereign architecture like Anven, transforming raw telemetry into a